Hello everyone. In this video, I am explaining how to find the summation of binomial series. We know the binomial expansion of a plus b whole power n. That is the standard binomial expansion. nc0 a power n plus nc1 a power n minus 1 into b plus nc2 a power n minus 2 into b square plus so on up to ncn into b to the power n. Now, before finding how to get the sum of binomial series, first let us define what is a binomial series. Using the standard binomial expansion, now I can apply it for 1 plus x whole power n, which is equal to 1 plus n by 1 factorial into x plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 into n minus 2 by 3 factorial into x cube plus so on up to infinity. Using the same binomial expansion, here a equal to 1 and b equal to x, and nc1 values directly I have written nc2, this is the value, nc3, this is the value. Now this series is called as binomial series. This is the binomial series. Using the same standard definition of a binomial expansion, I have defined the binomial series. Binomial expansion of index n has n plus 1 terms, but binomial series is having infinite terms. That is the difference between binomial expansion and the binomial series. Now, as it is a series, a natural question arises about the behavior of this series. Behavior of the series means, is it convergent, is it divergent, or oscillatory series? Now, this series is convergent for mod x less than 1. That is, x is a real number which is in between minus 1 and 1. In this case, the series is convergent. Therefore, this binomial series is defined for mod x less than 1. This series, you name it as equation 1. Now, in this series, if you replace x by minus x, then we will get 1 minus x whole power n equal to 1 minus n by 1 factorial into x plus n into n minus 1 by 2 factorial into x square minus n into n minus 1 into n minus 2 by 3 factorial into x cube plus so on. So there is an alternative plus and minus sign if you have 1 minus x whole power n. Now, to find the summation of these kind of binomial series, we need some useful formulae. Let us see how to derive those useful series which help you to get the summation of binomial series. So, any series which is in this form is called a binomial series, and if you are asked to find the summation of binomial series, let us see how to get the summation. So first thing is you have to replace n equal to p by q, where p and q belongs to z, q not equal to 0. Do this in equation 1. So what you are going to get, 1 plus x to the power p by q equal to 1 plus n by 1 factorial. N is nothing but p by q. So p by 1 factorial into 1 by q into x plus here again p into p minus q divided by 2 factorial into x by q whole square. Here x square is there, q square after taking the LCM. N is to be replaced with p by q minus 1. After doing all the simplification, we will get it in this form plus so on. Similarly, put n equal to p by q in the second equation. This is the second series. So, you will get 1 minus x power p by q equal to 1 minus p by 1 factorial into x by q. P by q, I will write x by q together, p individually, plus p into p minus q divided by 2 factorial into x by q whole square minus so on. This continues. Similarly, if you put n equal to minus p by q in equation 1 and equation 2, what we are going to get is 1 plus x to the power minus p by q, which is equal to 1 minus p by 1 factorial into x by q plus, as you put n equal to minus p by q, so minus p by q minus 1, you can take minus common, you will get p plus q in this case. So that is p into p plus q divided by 2 factorial into x by q whole square minus so on. Alternative plus and minus, but the difference is here it is p plus q. Similarly, in the second series, if you put n equal to minus p by q, you will get 1 minus x to the power minus p by q equal to 1 minus of minus, it becomes plus here, p by 1 factorial into x by q plus p into p plus q by 2 factorial into x by q whole square plus so on. So these four series are very important while evaluating the sum of binomial series. If the given series is in any one of these forms, then that is a binomial series, and this series format has to be remembered to get the summation of binomial series. When there are four formulae, to avoid confusion, the 2 points you have to remember here. See, when the index is positive, that is p by q, n equal to p by q, positive value, then you will have p minus q. When the index is negative, minus p by q, then you will have p plus q. And one more thing is, when the sign of the index and this middle sign both are same, then in that case all terms are positive. If sign of the index and this middle sign are of opposite sign, then there will be alternative positive and negative sign in the RHS of the series. See here, both are having the same sign, positive sign, so all terms are positive. Here also, this middle sign and the index sign both are same, negative, negative. In that case also it is positive. Same sign means all terms are positive. Opposite sign means there will be alternative positive and negative terms in the RHS of the series. These 2 points you have to remember to avoid the confusion that which series has to be applied. Now let's see how to identify binomial series if a random series is given to you. That is, features of binomial series. Consider this series. This is a binomial series because the first feature is there is an additional factor in the numerator and denominator of every successive term. See, in the first term is always 1 here, second term, third term, fourth term, these are successive terms. There is an additional factor. Here there was no 5. Here there was no 12. Next there was 5, 12. Next again 8, 18. So there is an additional factor in both numerator and denominator of every successive term. As you move forward, terms will grow here. More factors gets added up. Now second feature is that the successive factors of the numerator are in AP whose common difference is denominator of index. The successive factors, see here, 2, 5, 8, 2, 5, 8, these are all in AP. Successive factors of numerator, these are in arithmetic progression. The common difference is denominator of the index. How the index is n equal to p by q. So the denominator of the index is q. The common difference, whatever you will get here in this AP, is equal to q. Q equal to common difference of arithmetic progression. See here, 2 to 5 common difference is 3, then 8, that is 3 again, so q equal to 3. Next feature is the denominators of the terms are factorials of 1, 2, 3, 4, etc. Now see, this is the denominator here. Here it is the denominator. This is the factorial of 1. Here I can write 6 ones are 6 twos. Therefore, the denominators of the terms are factorials of 1, 2, 3, 4, etc. This is 1 factorial. This is 2 factorial. By just taking 6 common, 2 factorial. Then similar, here you will get 3 factorial and so on. Next, one more feature is the power of x by q in each term is equal to the number of factors in the numerator and equal to the factorial number in denominator. See, for example, if I write it in this form, 1 plus 2 by 1 factorial into 1 by 6 plus 2 into 5 by 1 into 2 into 1 by 6 whole square plus so on. So here it is x by q. The power of x by q is equal to number of factors in the numerator. Numerator there were 2 factors, so it is 2. Here there was 1 factor, so power of x by q is 1, which is same as the factorial number in the denominator. The factorial number in the denominator is 1 here. Here the factorial number is 2. So power of x by q is 2. And then factorial number is 3. The power of x by q will be 3. And that continues. So these are the features of binomial series. That will help you to identify the given random series as binomial series. With all this basic knowledge, let us go to the problems. Find the sum to infinity of this binomial series. This is a binomial series, so I want to find the sum of this series. Name it as S. 1 plus 2 by 6 plus 2 into 5 by 6 into 12 plus 2 into 5 into 8 by 6 into 12 into 18 plus so on. Now there are 4 standard forms. See here, which I have written before. These are the 4 standard forms. Out of these forms, I have to use the appropriate form. So for that, I have to bring it down to one of the standard form. Let us see how to do that. First term should be 1 plus. Then this is 2 by 1 factorial into 1 by 6. I'll write it like this because this is the second term now. P value is 2 by 1 factorial into 1 by 6. This is x by q. Then here 2 into 2 plus 3. 5 can be written as 2 plus 3. That will tell you the value of q. Then here 2 factorial because 6 into 1, here 6 into 2. Then 6 common here. 6 into 6 means 6 square. So that 1 by 6 whole square outside. Then 1 into 2 means 2 factorial. Plus similarly 2 into 2 plus 3 into 2 plus 2 into 3 divided by, this is 3 factorial into 1 by 6 whole cube plus so. Now compare this with these 4 standard forms. Which form satisfies the above series? See, that is the last one. All terms are positive means either the first one or the last one. First one I will not choose because here you have P plus Q, but in the first one you will have P minus Q. When the index is positive, you will have P minus Q. Therefore, here there is P plus Q, therefore I will choose the last one. So that is equal to 1 minus x to the power minus P by Q. I have to find out PQ and x value 1 by 1. P value is nothing but compare it with this. P equal to 2, then Q equal to, Q is the common difference, that is 3, then x by q equal to, here what you value have 1 by 6. This implies x equal to q by 6, q is 3 by 6 is nothing but 1 by 2. Let us substitute that here. 1 minus 1 by 2 whole to the power minus 2 by 3, which is equal to 1 minus 1 by 2 is 1 by 2 to the power minus 2 by 3. So a power minus 1 can be written as 1 by a, 1 by 2 to the power minus 2 by 3 becomes plus 2 by 3. This is equal to 1 by 1 by 2 whole power 2 by 3, because 1 to the power any value is 1. So that is 2 to the power 2 by 3. Therefore, the summation of this series is 2 to the power 2 by 3. This is how we get the summation of binomial series. Now, second problem. Name the sum as yes, 1 by 15 plus 1 into 6 by 15 into 30 plus 1 into 6 into 11 divided by 15 into 30 into 45 plus so on. Now look at the given series. 1, next is 6. So you have to add 5 to this 1. So common difference is 5, means q equal to 5 you will get. Then first factor of this AP is 1, therefore P equal to 1. Here itself you can identify that. Now you have to rearrange this to apply the formula. So as per the formula, there should be first term 1, but that is not there. Anyway, rearrange the remaining term. So this is equal to 1 by 1 factorial into 1 by 15. So I have written this 1 by 15 separately because that gives you x by q, plus 1 into 1 plus 5 by 2 factorial into 1 by 15 whole square. 15 ones are 15 twos are, so 15 into 15, 15. Here 1 by 15 whole square. So the index of x by q must be same as number of factors in the numerator as well as the factorial number in the denominator. It is 2 factorial, means power of x by q must be 2. Similarly, 1 into 1 plus 5 into 1 plus 2 into 5 divided by, this is 1, 2, 3. 3 factorial into 1 by 15 whole cube plus so on. So this is equal to all terms are positive. All terms are positive means there are two possibilities. One with the index p by q, another with the index minus p by q. There are two possibilities. That is, one is 1 plus x to the power p by q, or 1 minus x to the power minus p by q. But the first possibility will not come because here you have p plus q. P plus q comes in the last possibility. Therefore, here we will have 1 minus x to the power minus p by q minus 1, because this formula is 1 minus x power minus p by q is equal to 1 plus p by 1 factorial into x by q plus p into p plus q by 2 factorial into x by q whole square plus so on. But here it starts with the second term. Therefore, this one term is not there, means it will be extra here. We want the sum of these many terms, so this has to be taken to the left hand side. This is equal to, we got the value of pq, then I want x by q is 1 by 15, so this gives you x equal to 1 by 3. So substitute 1 minus 1 by 3 to the power minus 1 by 5 minus 1. So this is equal to 1 minus 1 by 3 means 2 by 3 to the power minus 1 by 5 minus 1. So this is equal to 1 by 2 by 3 to the power 1 by 5, that is 3 by 2 to the power 1 by 5 minus 1. So this is the summation of the given infinite binomial series. Now the third problem, let us name this series as yes, yes is equal to. Now look at the terms of the series. This is a binomial series here. First term here 5, next 5 plus 3 8, then 8 plus 3 11. So the numerator terms are in AP and the denominator can be expressed as a factorial. So of 1 to 3, 3 ones, 3 twos, so it is 2 factorial. Here it is 3 factorial and so on. But now you have to do some changes here. That is because here this is 1 by 16 is nothing but 1 by 4 whole square. You can write, then 1 by 4 whole cube. So 1 by 4 whole square means 2 factorial you can have. Here also 1 by 4 whole square. Index x by q's index is 2, factorial is also 2, but numerator also should have factors 2. But there are no two factors, there is only one factor. So which is the previous factor than 5? So 5 plus 3, 8. 8 plus 3, 11. So 5 minus 3, that gives you 2. So what you should do is you have to multiply this entire series by 2. So 2s is equal to 2 into 5 by 3 into 6 into 1 by 16 plus 2 into 5 into 8 by 3 into 6 into 9 by 1 by 64 plus 2 into 5 into 8 into 11 by 3 6 into 6 into 9 into 12 into 1 by 256 plus so on. This I have done because now it is 2 factorial, means 2 terms should be in the numerator and index of x by q must be 2. Now it gets satisfied. So this is equal to, so I can write 2 into 2 plus 3 divided by, this is 3 ones, 3 twos, means 2 factorial, 3 into 3, 3 square. So already you have this as 4 square. So here you have 3 square and here it is 4 square, means 4 threes are 12. So it is 1 by 12 whole square. So plus 2 into 2 plus 3 into 2 plus 2 into 3 divided by, this is 3 factorial into, this is 4 cube. Here 1, 2, 3 means here it is 3 cube. So 4 cube into 3 cube, that is 4 3 is 12. 1 by 12 whole cube plus so on. Here all terms are positive, therefore you have either 1 plus x to the power p by q or 1 minus x to the power p by minus p by q. But as there is p plus q, the last one will come, the list formula. What is this formula? 1 minus 1 plus n by 1 p by 1 factorial into x by q plus p into p plus q by 2 factorial into x by q whole square plus so on. Now compare it with this formula. Here it starts with the whole square. These two terms are missing. Therefore, these have to be taken to the left hand side. That is equal to 1 minus x to the power minus p by q minus 1 minus p by 1 factorial into x by q. So these two terms are not there in the series, so they have to be taken to the left hand side. Now here, what is the value of p? P equal to the first factor, that is 2, q equal to the common difference, that is 3, then x by q equal to 1 by 12. So x equal to 3 by 12 means 1 by 4. Substitute all these values. 1 minus 1 by 4 whole power minus 2 by 3 minus 1 minus p is 2 into x by q is 1 by 12. So this is equal to 2s equal to, this is 3 by 4 to the power minus 2 by 3. This is 2 ones are 2 6. Minus 1 minus 1 by 6 is minus 7 by 6. So simplify, 2s is equal to, this becomes 4 by 3 to the power 2 by 3 minus 7 by 6. So finally s is equal to 1 by 2 into 4 by 3 to the power 2 by 3 minus 7 by 6. This is the final summation of the given series. I hope you understood the concept. Thank you for watching.